0, 0, 0, 0, 0, 0. So like it would tend to 0 only. So it's exactly 0. I know in limits we consider
Okay.
exactly. Yeah. Infinity power 0. So here you might have this doubt that if we see it from this perspective, answer should be 1. But if we see it from this perspective, it should be infinity, because infinity multiplied, I mean, 0 number of times. So I mean, so when we start limits, first thing is the understanding, have clear understanding of what is approaching to meaning, what is exactly meaning, uh, and what is infinity, what is not defined, all of these things. Okay, so let's start from there only.
Yeah.
Okay, also, how's your limits? What's your like progress in this chapter? How much are you able to do? What do you face problems in generally?
I wouldn't say it's my best chapter.
Okay.
Mostly the L'Hopital rules and all of that.
Okay. Okay. So I'll just quickly write few things. Let's say you have 1 by 0, 1 by 0 plus, 1 by 0 minus, 1 by infinity, 0 by 0, 0 by approaching 0. You can start to, r- think what could be the answers of these small things. Approaching to 0 by 0. Okay. Let's start. See, 1 by 0 is not defined. Okay.
Yeah.
1 by 0 plus. So a very negligible value, smaller than, greater than 0. So like 0.0000, you cannot write 1,
Yeah.
something like that. So it's like infinity. What would this be?
Mm-hmm. Negative
Minus,
infinity.
yes, this is equals to, okay, 1 by infinity, 0. 0 by 0, what do you think?
0 by 0 not defined.
Correct. It is not defined because you see this is permitted, but you're dividing it by 0. So that means this case. So not defined. Okay. What is this? So it's like something like 0 by 0.0000001,
0.
let's say. Yes. Correct. Also, you might have this doubt. What is the difference between 0 plus, 0 minus, or approaching to 0? So they are the same thing only. By convention, whenever we say approaching to 0, so generally we take the positive one. So like 0 plus.
Mm-hmm.
Okay. Next, what about this?
That would be not defined.
Correct. Okay. What about this?
1.
No, that's actually indeterminate. So this is one of the indeterminate forms in maths that we have. This is indeterminate, not 0 by 0. Yeah, because you cannot determine the value of it. Why?
Mm-hmm.
See, let me just give you, few cases. Indeterminate. Okay, let's say it's something like this. What is the value of this? Is it 10?
Mm-hmm.
Okay. Let's say it's this. What is this now? 1 by 2?
Yeah.
So it's varying with every situation. So that's why it's indeterminate.
Okay.
Okay. Next is 0 into infinity, approaching to 0 into infinity, infinity by infinity, infinity plus infinity, infinity into infinity, infinity minus infinity. What do you think this is? Let me give you also, sorry, one more suggestion, a hint. Whenever you see infinity, try to write it like this.
Okay.
Okay, that will make it easy. So this is actually 0 by 0 plus. It should be 0.
Yeah.
Okay.
Mm-hmm.
Next is this thing. So this is approaching to 0 by 0 plus. So again, indeterminate form, because this and this is
Mm-hmm.
the same thing, right? So I'll write IF, indeterminate form, not integrating factor. What is this?
Indeterminate.
Yes, because this also reduces to 0 plus by 0 plus. So this is also IF. This is what? Infinity. This is infinity, not infinity square, because infinity squared is same as infinity only. What is this?
Wait, 1 second. Infinity minus infinity.
Yeah.
That's also infinity or
No.
indeterminate.
Yes, indeterminate. Because see, just imagine. For example, you also know that infinity is just a representation. For me, infinity could mean a different thing, right? So what if this infinity is greater than this? So it would be a positive quantity. If this infinity is greater than this, so it would be a negative quantity. So how it's not determined, right?
Yeah.
Okay. Now another few sets of things. So 0 power infinity approaching to 0, infinity, infinity 0, infinity approaching to 0. Like, this is the most fundamental thing. Actually, entire chapter gets over, but people are confused in this thing only. Okay. 0 power infinity. So 0 multiplied infinite times. So that's 0 only.
Zero.
Okay. Approaching to 0 multiplied infinite times. So assume something like zero point 0.1 into zero point 0.1 into zero point 0.1. Do you see how this would be something like 1 by 1 0 0 0 0 0 0? So like it would tend to 0 only. So it's exactly 0. In limits we consider
Okay.
exactly. Yeah. Infinity power 0. So here you might have this doubt that if we see it from this perspective, answer should be 1. But if we see it from this perspective, it should be infinity, because infinity multiplied, I mean, zero number of times. So I mean, there's a confusion. So this is actually not defined. Don't say
Okay.
indeterminate. Okay. Now infinity power approaching to 0. That's
Infinity.
no, that's indeterminate form.
Okay.
Approaching to 0 power 0. So this is something finite only. So this is 1, because a power 0 is 1, where a is any finite quantity. So a should not be infinity. That's it. And a should also not be, one more thing, we'll see that. It should not be 0 also, actually. Okay.
Mm-hmm.
Then this is also in indeterminate form.
Mm-hmm.
This would be 0 only.
Yeah.
And what do you think this is?
Not defined.
Yes, correct. Okay. So how many? Okay, let's just move forward. Okay. So let's say you have, sometimes you have this thing, this kind of expression where x is a constant, actually, not a variable. Your variable is n, and your n, is a tending to, you can say, infinity. And let's say it's a natural number. So basically, n is a very large natural number. So do you see how you can like break it into cases? Because when my x is, let's say, between -1 to 1, do you realize how if I increase the power, the output will be lower, right? When my x is plus -1, so it's very easy, right? Let's say x is -1, so it's -1 power 2n, right? Can I write this as -1 square n? So is this just 1 power n? Now n be anything, answer is 1 only. Similarly for +1 also, right? And now the last set of interval, which is what? Minus infinity to -1, should it be right? 1 to infinity, correct? For this interval, whatever power is there, it will be tending to infinity, right? As you increase n. So I can write for x this. I can write x power 2n would be 0. For this, x power
Yeah.
2n would be 1. And for this, x power 2n would be tending to infinity.
Mm.
Perfect.
Yeah. Okay. Got it.
Okay. Now another this, and finally this. What do you think the answer for these two are?
Indeterminate.
First one,
Not
okay.
indeterminate.
No, this one is indeterminate.
Okay.
This one, it's just exactly 1 multiplied infinite times. That's 1 only.
Oh, okay then.
Yes. So really important thing. So we discovered all the indeterminate forms. So that's 0 by 0, infinity by infinity, 0 into infinity, uh, infinity minus infinity, 1 power infinity, infinity power 0, and 0 power 0. Okay. let's compare if what we have written is correct or not. So 0 by 0, infinity by infinity. Okay. Now, actually, one more thing. Wherever I am writing here 0 or 1, they are all approaching to, not exactly 1. So let me just write it correctly only then, because otherwise in day-to-day life we don't write it like this, right? We just write 0 by 0. But anyways, you can write like this. Okay.
Okay.
So this is also approaching to. Okay. So this is correct. This is correct. This is correct. This is correct. And this you can obviously write as infinity as approaching to 0. So this is correct. This also you can write like this only, and this is correct. Okay. So how many are total? 7, right? 3 plus 3 plus 1, so 7. 7 IF indeterminate forms. Okay. Now the L'Hopital rule that you use are only valid for these two. I mean, very basically, you see you can very well say that this form is technically this form only. Even this form is technically this form only. So yeah. So at the very basic, we can say that whenever you have approaching to 0 by approaching to 0, you can use L'Hopital,
Yeah.
right? So you can use this L'Hopital rule, which is what? Just differentiating numerator and denominator individually, right? Okay. Now, do you have idea about these two, RHL, LHL, RHL, and limit at a point?
Yeah.
Okay. So when does limit?
Many students practice maths regularly, but still don't improve. Because the same mistakes keep repeating, and no one tracks them. In exams, this turns into confusion and blank moments. With one-to-one mentoring, every mistake is corrected, and real improvement begins.